Okay, welcome everybody to the lecture section of this evening's proceedings. And as you can see, we have a group of speakers this evening. Their names are up on the screen, but we have a group from St Andrews. They're all fourth-year undergraduates. We've got Isla Filipowicz, Henry Lodge, Isla Farrell, and Thorfin Gunn, who are going to talk about their undergraduate mapping project in Qassiarsuk in South Greenland, which received some support from the Edinburgh Geological Society. And part of the quid pro quo for getting the support is they come and tell us what they did with the money. And as Mark says, we are able to fund whatever meets the standards we set. And he didn't say it, but actually we do set quite high standards. So I'm really looking forward to seeing what came of this support that we provided to this group. But I'm also very interested to hear what the title that they proposed for advertising the lecture. It's not just undergraduate mapping project, it's Mapping and Other Adventures in South Greenland. So I think we're in for a very entertaining and interesting talk tonight. So I'll hand over now to the speakers.
Good evening. Thank you for having us. We're very grateful for the pizza and for you coming to listen to our talk today. I'm Henry. This is Isla, Ula, and Thorfin. We're going to just go through a sort of overview of our trip, the basics, what each day looked like, and then we'll each go into a bit of specifics about our individual research, geologically speaking. And yeah, so I hope you enjoy. Next slide. So we got funding from a few places, and we'd like to say thank you to you guys for your funding. This is a sort of overview of all of our funding, including Travel Lunch, who gave us freeze-dried food to our heart's content, which was obviously wonderful, but yeah, we ate a lot of that, and maybe too much. So a massive thank you to you guys for the funds that you gave us towards our trip. It was life-changing for all of us, and yeah, we're going to be grateful for that forever. So thank you.
Okay, so the previous work of other St Andrews students and staff members in the Garda province has been the inspiration for us to pursue an expedition to Greenland as well. This is due to the logistics and safety issues in the Arctic, quite an expensive trip. So we have to go down the funding route and go get support. And other groups have done this before us. They have helped us a huge amount, even people who graduated years and years ago. We have still got their support and their advice. And as said, also staff members from St Andrews go there. So we have a couple of people who specialize in the geology of the Garda province who have been very supportive of our trip as well. And we also hope to inspire future groups to do this because it was an amazing experience and we all grew as people and also academically. So basically our plan was to go to Greenland and map the areas that we've chosen and looked at in advance and read about, and then collect some samples and some quantitative data for further analysis that most of us then turned into a dissertation afterwards.
So lab might work? Yeah, just very good. So we've got a little bit talking about the preparations we've done, some of the precautions and setup we did, and this is partially really for any students in the room looking at doing expeditions for themselves. I'm not entirely how it works with how exactly it works with Edinburgh University and course study, but our preparation for this fieldwork initially began about September, was it 2023 or 24? 23. When we initially decided we wanted to go a bit further out the country for field work, and then sort of serious prep, sort of getting project plans, where we actually wanted to go in Greenland, etc. That sort of happened about December last year. And then we managed to get what equipment was available through the department, so tents, advice, food, and through funding we were able to get stoves and various other bits and all the food we needed for 6 weeks out there. pack it up all in my room, actually. It took up quite a lot of space in my room for about 3 weeks, and then ship it off about 2 weeks before we went out. So the food, like I mentioned, we were out there for 6 weeks, and we had to be pretty much self-sufficient on our own stuff for 2 reasons. One is that we're going to be eating quite a lot, and we're going to be quite far away from any shops because, well, Greenland does have shops, but they're fairly few and far between. And we were going to be working about 8 kilometers away from the nearest village. And if you've ever been to Greenland, it's prohibitively expensive for anything. I think we went and bought some fresh food twice, and it cost us about £70 each time for some eggs and butter and stuff like that. So it's really very expensive. So it saves us a lot of money by sorting the stuff out before. And again, sponsors are very helpful for that. Safety. So we had to have a pretty comprehensive safety plan and risk assessment set up before we went out. Again, our lecturers were really invaluable in this and gave us a lot of good advice on how to do this properly so we can actually conduct our field work safely and have the university sign off on it. So it was a fairly significant amount of planning, but for any students who are interested in doing this sort of stuff, it's very achievable with support of lecturers and staff and other students.
Yeah, so this was our journey there, which was a bit of an adventure on its own. We started off very early in the morning in Dundee, and then we got a bus down to Edinburgh Airport, and then we ended up getting 2 flights, and we ended up landing in Qassiarsuk, which is across the fjord from Qassiarsuk. So then we had to get a boat with all our boxes and all of our bags over to Qassiarsuk, and yeah, we ended up, our host who we were staying with very kindly brought her very old white Toyota down, and we packed it packed it as best we could, and then we were off. So yeah, as I said, we stayed with a local. She was amazing. She gave us food. We stayed on her farm. She was a sheep farmer. That's the white Toyota previously mentioned. She was really cool. She was a local. She was the last female to indigenously hunt. So she hunted whales and seals off of her kayak, and her and her family were very good to us. And we left a lot of extra food with them, which they were very grateful for as well.
So the area that we went to, we did a lot of reading about, and we were sure it was very interesting geologically. But then on arrival, we also acknowledged that this is a very important area culturally and historically, because this is where Leif Erikson first landed in Greenland. There is little settlements, little huts there, and a lot of information boards, as you can see. So we were standing not only on very, very old and interesting rocks, but also on a very big piece of culture.
No, it was quite important in the planning that we said we wouldn't hit any of their nice old sort of 1,000-year-old Viking settlements with hammers.
They're not in situ though, so we don't want them.
Yeah, and because we're not geologically interested in them. Yeah.
So yeah, this is on the right-hand side. That's the house we stayed in for about 5 weeks. Obviously, being very off-grid, sustainability was really important, and the farms and a few farms around us were powered with a hydroelectric pump, which was just upstream of that waterfall. And there was actually so much electricity produced from it that they told us to keep the lights and the heating on all the time so they could use up all the lecky. This was on the left-hand side. That was the meal we were greeted with after our 16-hour journey, which was some really nice fish and some fresh prawns, which were, yeah, much appreciated at the time. So yeah, these are some of the stuff we saw, not geologically, but some of the other stuff we saw when we were there. Top left, obviously Arctic foxes. We only saw a few of them, but that was really cool to see. In the middle is rock ptarmigan, which had a really weird call. Top right is lambs. While we were there, it was lambing season. There are about 25,000 sheep on the peninsula we were on, and a few of us helped feed the sheep and look after them, and yeah, that was very cute. In the bottom left, I got really into the lichen when we were there. This is a specific one called Elegant Sunburst, which is this really nice orange color, and it happened to grow on carbonate-rich rocks, which is really interesting for Henry. So we ended up looking for that specific lichen. In the middle is a sea eagle. We saw a couple mating pairs while we were there, which was really nice. And in the bottom right were these caterpillars, which seemed to be everywhere for the first few weeks in our books and in our bags, and then one day just seemed to disappear.
So for our typical day in the field, we'd get up and obviously we had a lot of sunshine because the sun only set for a couple of hours in the night, and so we weren't too harsh on ourselves. We got up around 7:30 or so, and then just ate this ginormous vat of porridge, which took up most of the table. And have you guys eaten porridge since? I can't anymore. I think I'm done. My porridge days are over. But and then we'd be out in the field, and that was lovely. We went out in 2 pairs and left someone at base camp most days to keep an eye on sort of local news and things in case of polar bears or things like that. And we spent, it was beautiful. The scenery was stunning. I think there's some scenery pics coming up. But yeah, there's beautiful fjords and glaciers everywhere. So it was very nice. And obviously very interesting geology as well, which we'll get to. And then we'd come back in the evenings, and there's Ula eating a travel lunch and doing her office work so that we'd be ready for the next day in the field the following day. And we really fell into that routine. I think it worked quite well for all of us. There was a few days off we had as a group due to weather, like blizzards and other things out of our control. But for the most part, we were out every day. I think we did about 30 days of field work in the 37 days we were there. So it was quite good going, I think. Yeah.
First of all, we're going to introduce my bit of work, and the main reason we're doing me first is because I was out there to do a mapping project specifically, while the rest of them were doing a dissertation for a bachelor's. So the scope of my work was a little bit more constrained and was really focused more on just mapping the rocks in the area. So it makes it a really good intro for you guys. So we'll try and keep it open because we understand there'll be some here who are really academic, some people who are just a bit interested in the geological side and not so academic on it. So we'll try and make sure it's interesting for both of you and not too over the top. So here's our one version of our combined geological map finished from being out there. So we managed an area about trying to work out how many kilometers square total it was. It's about a bit more than 15, I think. So my area was in the bottom left. Henry was working at that nib on the top. He was doing a bit more detailed mapping. Isla was the area on the coast on the right, and Ula was doing the sort of central block. So we can see sort of 6 distinct groups or 6 distinct units that we identified while we were out there. And we did compare to work in literature, which has been done nearby. So you can see the sort of basement granites and granodiorites that is sort of fairly standard coarse igneous units, not that dissimilar from what you'd see in places like the highlands in the Cairngorms, for example. And then you've got your more exciting, the diatremes coming through, which are kind of like these eruptive pipes that Henry will talk about a bit more in his section. 2 different type of dikes that have a slightly different trend through the region, and there's a lot of structural information and data that those can give us that Ula will probably elaborate on, and Isla as well, because that's really what they're dissertations are based on, and then also this series of gneiss, which mostly appeared around the coasts, but was far less prominent. So it was geologically a very interesting area to map, and I apologize if any of you like sediments, because we went here to avoid them. So, yeah.
So the title of my dissertation is The Structure and Tectonic Setting of the Igneous Dikes Swarms. It has now been revised, of Qassiarsuk, Greenland. So as Thorfin already mentioned, we had 2 different dike types in the area. And could I have the next slide, please? Actually go forward another one. So here is a bit more on the dikes with some pictures. We had those very prominent trachytic dikes, which were very brown, standing proud for the environment, usually quite large, features that were really hard to miss. You could like walk along them like little pavements. Here is some average measurements. I'm not going to bore you with the specific calculations for that. And then there was a bit smaller basaltic dikes, which also had a similar trend, but it was off by 9 degrees. And they were significantly smaller and less frequent through the area. We initially also identified something that we called the red dikes, which we then found out was probably just part of the diatreme alteration. And why do we care about these dikes? Go back. In rift zones, as we know, the Gardar province is part of the ancient Gardar rift zone. The dike direction can represent the sigma free of the area, or is perpendicular to the sigma free, which is the minimal principal stress of the area. So by looking at the average trends of the dikes, I can make then interpretations about different drifting events. So if we can then go forward. So as originally said, I was looking at one dike swarm, and then after coming back, I quickly realized that my dike swarms were actually different. I tested them against each other statistically for both width and trend, and they're not the same geological feature. They're both significantly different, and their magmatic composition also doesn't really follow the magma evolution sequence of a rift zone. So I am currently in the process of finishing up my tectonic history for the area and like writing everything up. Those are very old rocks, and it was a very long time ago. So there's a lot of ambiguity within what exactly happened to them in between different rifting events. But what scientists in literature agree on is the Garter Rift was part of the breakup of Columbia, but which would have caused drifting in 2 episodes. However, the Laurentia and Baltica, after breaking up, came back together to form Rodinia. And what happened in between is also not very certain. And then we, of course, have later, around 69 million years ago, also the rifting of the Labrador Sea, which also was a potential rift influence. So I'm now trying to discuss and basically finish up my dissertation and talk about the 2 different dike swarms and what I think they represent with their 2 different directions. And I think we have one more slide. So yeah, here is also the distribution of my orientations of the dikes, and the trachytic ones, again, were a lot more frequent, so there's a lot more data for them.
Yeah, so this is my study. I'm doing a paleomagnetic study of the igneous events in Qassiarsuk, but more specifically the dikes, because they've ended up giving me much nicer data than all the others. So this was me. I went out, made a nice map. That's me mapping and sampling. I took orientated samples while I was in the field, so I could then come back and use them for further analysis. And on the right there is me. I spent about 30 hours drilling and cutting all of my samples, which was good fun. So I chose paleomagnetism because it's a really interesting way to age rocks. I'd never really heard of it before that, and I've become really interested in it since then. So this is reflective light images. On the left is the basaltic dikes Ulla has mentioned, and on the right is the trachytic dikes. I did this initially just to have a look at the oxides and sulfides in the samples. And on the left, you can see the sulfides are in the yellow color and the oxides are in that kind of bright gray. You can see in the basaltic dike, they've not really been oxidized. They're quite fresh looking. And in the trachytic dike, they're really oxidized. I won't bore you with my 200 hours of lab work, but essentially, you can ask me after. On the left is my final paleopoles for the basaltic and trachytic dike, and with initial aging, I'll find a slightly better database, but with initial aging, it suggests that there's about 300 million years between the 2. So definitely from different rift zones, which is really cool. And then to assess the reliability of these results, I did magnetic characterization, which is looking at what type of magnetic minerals are present, like magnetite and hematite, and also the coercivity, so if they're single or multi-domain. And on the right, there is one from the basaltic dike, and it has this really nice curved peak, which is called a Hopkinson's peak. And that's really indicative of single domain magnetite, which helps to prove that the results I have from the paleopoles are nice and reliable, and I can use them for official dating, which is really nice.
So Qassiarsuk the town of Qassiarsuk is very geologically famous because it has these Gardar lava sequences, but rather than almost all lavas on Earth, which are made of silicate minerals, they're made of carbonate minerals. So usually what you'd expect to find in limestones is being erupted out of the Earth's crust. And the formation of these lavas that are made of carbon as the predominant network former in the minerals is still the subject of some debate, but they're likely to come from very deep and be quite related to kimberlite forming processes, which is where we get all of our diamonds from. Next slide, if that's okay. So these rocks are really unusual. They're full of quite strange minerals, and they often made my head hurt when we were in the field because they were very fine grained and I couldn't really, put a story to them that was satisfying out there. So there's me having a little nap, feeling overwhelmed. And on the left, you can see them. They're this horrible grey and brown color. And here they've been erupted really violently and entrained bits of the wall into them, which is these angular blocks on the left in the blocks of the wall that have been pulled off by the force of the eruption. Next slide, Thorfin. So they are volcanic systems, which I could tell whilst we were out there, which was nice. And here I am in the snow having a look at something. And on the right, again, are more of these fragments of wall rock that are in the pipe of the volcano. And you can see there that there's these lapilli, which are small droplets of melt. And usually lapilli are formed from being thrown into the open air, where the really hot magma comes together in these circular features and fall back in. But that is not the case here, seemingly, but we'll get to that. So yeah, these rocks are 1.3 billion years old, so they're older than all complex life on the planet. And there's only 600 other outcrops like them on Earth that we know of at the moment, so they're quite rare. And in the 1960s, people went to our area and said that they'd seen these things, but literature on carbonatites, which are these carbon-rich rocks, has come on such a long way since then, we thought we'd go back and have another look. And yeah, I found that they are indeed carbonatites, and I've put them into the new classification, and hopefully we'll be publishing a paper about that quite soon, which is exciting. So next slide again. Yeah, so the classification was revised in 2005 and then again in 2022. So we have a new system by which we can name them, which is exciting. And then I've used a variety of lab techniques to reach those conclusions. Next slide again. So here you can see them really up close. These are the inside of those lapilli, which are those circular features on the carbonate backdrop, and they've been formed from the force of the eruption has driven the magma together because there's so much power behind it into these, which is a very unusual way of forming lapilli. So that's interesting again. So yeah, as I said, I've confirmed that they're carbonatites and found some other rare igneous rocks there, which are common throughout this province, but across the globe they're very rare. So it's interesting to see more of them. Yeah. And yeah, in future, hopefully some isotope work will be done just to confirm my findings, but I didn't have enough funding for that, so it was out of my budget. Anyway, yeah. So in the future for us, we're all finishing our dissertation now, and then we're hoping to publish our maps because the area, as I said, hadn't been mapped for a very long time. And some of us have come to interpretations that we think are of academic quality, hopefully, which is nice. And then we're also looking to support future undergraduate expeditions. There's a group going next year to just across the fjord from where we were. And we're giving them a lot of advice on how we went about doing things and what we would do it again how we would change it if we did it again. We've also used our funding to buy capital items such as stoves, which they can use, as we used another group's tents from the years before. So we're hoping that makes their process easier again. And yeah, we're hoping that people read our papers and read our dissertations and are inspired to do more adventurous field work and also learn more about the weird rocks that we found out there. So yeah, we'd like to say another massive thank you. We're going to stay up here for some questions if anyone has any questions. Perfect. And I'll hand back over to Alice.